All right, let's learn about instantaneous rate of change, also known as derivatives. So if we look over here, we can see f of x here, and then f of prime of x. So this is the original function right there. That's the original function, and that is the instantaneous rate of change. So if you see f of prime of x, that's just what it means. Anyways, so to get into this video, so there's gonna be two things covered here. So one, first principles, and then two, the power rule. So first principles is probably the way your teacher wants you to do it, but at the end I'm going to show another way to do it, which should be a lot quicker, like a lot quicker. So stay tuned for that. Anyways, this is the formula we're going to use. So f of prime of x, so instantaneous rate of change of x equals limit as h approaches 0. So h is going to be very close to 0, but not actually equal to 0, at least for the start. And then it's f of x plus h. So you're going to replace all the x's in the original formula with x plus h, and then, sorry, the original function with x plus h. Then you're going to subtract the original function, and you're going to divide all that by h. So if we look at this first one right here, I'm going to put in the formula right now, so I'll skip ahead to that. Okay, so this is what it should look like. And now, so you're going to take the original function, and in this one right here, for example, you're going to replace all the x's, so x, that x, and you're going to replace it with x plus h. So like this 3, for example, will become 3 bracket x plus h. And then the 2 will be like 2 bracket x plus h squared. Anyways, I'll show what it looks like. So I'll skip ahead to what that will look like. Okay, so this is what it should look like now. So you can see I replaced all the x's in the original function on this side here. So here, I'll just do a bracket right there so you can really see. So this x, or f of x plus h, now becomes the same thing, but now x is turned to x plus h. So you can see that one got replaced, that one got replaced from the original function, right? And now what you're going to do next, so you're going to square this one right here. So I'll zoom forward a little bit, but this one's going to get squared, right? So if you remember the how to square a bracket like that, it's going to become x squared plus 2xh, and then h squared, so plus h squared. Right, so anyways, I'm going to zoom forward a little bit so you can see what this looks like. Okay, this is what it should look like now. So I still have to expand the 2 into here. So the 2 is going to be expanded into all that, but everything else is pretty much expanded out. So one thing I will do right now is that I'm going to take away some terms here. So actually, here, I'll color this into different colors. So we can see this 3x right here is going to cancel out with that 3x, because 3x minus 3x is equal to 0, right? So I'll subtract those out. And then the plus 1 here is going to go with that minus 1. So that's going to go with this. And then, oh, sorry, I forgot to take out that one. And then that's about all we can do right now. So I'm going to finish putting out this 2 into the bracket, and then we'll see what it looks like after. Okay, so this is what it looks like now. So before we do anything else, we can take away another couple terms here. So we can take out this 2x, or 2x squared with that 2x squared, because it's plus and minus. So these two things can be taken away. And then this is what we're left with. So at this point, after all the terms have been taken out, you should only have terms with h in it. Okay, so you shouldn't have like a random like plus 1 here. You should never have that happen. They should always cancel out. So if that happens to you, make sure you look back, see what you did wrong, because you must have done something wrong. So because that can't be possible. So you're going to subtract, or you're going to divide by h on everything. So this is going to go away. and then this h is going to go away. That squared is going to go away. And then this h right here is also going to go away. There we go. And this is what you're left with. So what you're going to do now is, instead of setting the limit of h to 0, you're going to set h to 0. Okay, because h is going to now equal 0. So it's not going to be equal. H is now equal 0. So it's going to look like this. 4x plus 2, and then it's times 0 now. So you're not having that limit anymore. It's now like exactly equal to 0, which means if it's 2 times 0, then it's just going to be taken out, right? So you can just subtract that, and then, yeah, you're going to be left with 4x plus 3. So the instantaneous rate of change of f of x is 4x minus 3. So f of prime of x equals 4x plus 3. Now if we look over here to this one looks a lot harder, right? Like, look, see, it's cubed, but there's one other thing we can do which will make this a lot easier. So if we look back over here and we look at our original function, so here, I'll draw the original function down here. So 2x squared plus 3x, what was it, plus 1? Okay. So there's a pattern we can see here. So the pattern is, I don't know if everyone here can see it, but so actually I'm going to draw. So imagine there's an imaginary 1 up there, right? So it's x to the power 1. So when you, and then I'll draw 1 up here as well. So the way the power rule works is that you're going to take the exponent like this, you're going to move it to the front. So this is going to become a 2, and then you're going to subtract 1 from it. Okay? And then you're going to do the same thing to this one. So this one multiplied by 1 just stays as 3, and then it becomes 0 because it's 1 minus 1. So that becomes 0, right? And this one becomes 1. And then if you look at that, so if we do like 2x squared, you subtract 2 from the squared, and you multiply the 2 in, you're going to get 4x, right? You're going to get 4x, which is exactly what we had right here. See? And then the 3x, so 1 minus 1 equals 0. So you're going to get, and then you multiply the 3 in, or you multiply the 1 in, you get 3x. Or sorry, you get just 3, right? Because x to the power of 0 is just equal to 1. And then 1 is a constant, so it's not going to have an instantaneous rate of change, right? Because it's going to be the same no matter what. Like if you just had a function that was like y equals, or like a line that was just y equals 1, right? So it would just kind of look like this. It would never change, so it wouldn't have any slope to it, right? The slope is 0, so it wouldn't affect it at all. So you don't even have to look at the 1. In fact, when you're doing your calculations, you could just take the 1 right out, because that would have no effect. Would have no effect on it. So anyways, we can see that we can get the answer a lot quicker, right? See how these two answers are the exact same? So now if we go back up here and we look at this one, we could do the first principles. We don't have to. We can also just do, well, multiply the 3 in. Actually, here, I'll draw it out. So 3 multiplied by 4x multiplied by 4, and then x, 3 minus 1, subtract 2 times 2, x squared minus 1, and then plus 3, it's multiplied by 1. Here, I'll draw this one better. Bracket 1 multiplied by 3, x 1 minus 1. And then I'll leave out the 16 because it's a constant, we don't need it. And then, well, what are you going to get? You're going to get 12x squared minus 4, minus 4x, then plus 3. And if you go look it up, you'll find that that's the exact answer. So you can check all your homework solutions, and you'll find that using this power rule, so this is called the power rule, you can solve things a lot quicker, right? So obviously you might not be able to use it on a test, but you can use it to check your answer, right? Like we did right here. It took me like 10 seconds to check my answer. Anyways, that's all.